What's up, secondary math students? Mr. Thompson here. We're doing another video from home. I couldn't get into the school to record a video in the classroom, so here we are. I think this is going to be a pretty good one to do from home, though. I've got some good references and stuff for you guys. So we're in Unit 10C right here. This is what's going to be due, again, not this Friday, but next Wednesday. I think that'll be like May 6th or something. But we have two different ideas here in 10C. So we're trying to find the missing angles of triangles, and we're also comparing sine and cosine of congruent angles. So comparing sine and cosine, that's what we're doing with this first thing that's cofunctions. So really, this is going to be pretty simple, I think, to solve these problems. And there's going to be one of these problems on your quiz. But what we're doing here is we're basically saying that sine of one angle equals cosine of a different angle. And what's happening right here is we're just seeing that the difference between those two angles is going to be 90 degrees. Okay, and so 90 degrees, if you were to convert degrees to radians, that's going to end up being, so I'm just going to write this up here, 90 degrees equals pi over 2. And there really isn't you don't need to know this exactly for these notes, but the reason that I'm bringing this up is to show you guys this picture of the graphs, okay? So I think we can all probably see that. Okay, and so when we have the graphs of sine and cosine, what we can see is that the graph is exactly the same as far as the shape goes, okay? It just does this wavy thing. And both of them do the exact same shape. They're just offset a little bit. And the trick here is that they're offset by pi over 2, which is actually 90 degrees, okay? So we can imagine that from 0 to pi over 2, this is the difference of 90 degrees. And this is kind of a weird way to look at these graphs. I know we haven't usually looked at them like that before, but I'm kind of just showing that to you guys to demonstrate what you need to know going into this, okay? So really the big deal for what we're doing here, I'm going to get my extra phone, the one that's not taking the video, back to the calculator so I can show you guys what's happening. What we need to understand how to do here is, if I can find my freaking calculator, there we go. Okay, so we just need to see that, so for example, right here, sine of 50 equals 0.766. So if I get back into my calculator here, I think you guys can all see that, and I just go sine of 50, and it's really important to recognize that I have my calculator set in degrees, okay, and then I just press enter, and that gives me about 0.766, so that is correct, okay? So what we're looking for here is the angle that's going to give us that exact same decimal. So we're looking for 0.766, and so what that's going to be related to is 90 degrees, okay? So I'm going to have to do 90 degrees minus 50 to find that angle beta, okay? So I'm taking 90 minus our first angle. So let's just do that real quick. 90 minus 50 equals 40. Okay, so we're gonna test cosine of 40 degrees and make sure that it equals the same thing. Okay, so I clear that out and I go cosine of 40 and I press enter and hallelujah, 0.766, we're good. So I hope that makes sense. There really isn't like a big trick to this, you guys. This is just something that we kind of think you need to know going into next year. Okay, so now we're going to kind of go the other way. We're going to be looking for, right here, cosine of 32 degrees equals 0.848. Okay, so then we're going to be looking for sine of some angle. That's what we're going to try to solve here. And we're going to have that equal 0.848. Okay, so let's just double check one more time. Let's go cosine of 32 equals 0.848. We're in good shape there. So now let's try 90 minus 32, and let's just see what we get. I'm breaking a couple classroom rules here, you guys, because I'm using pen, which I always tell you guys not to do. And we're kind of just spitballing this first problem. Like, I haven't gone through the notes entirely. This is the first time I'm doing it. But I feel really good about this, so I think we're going to be all right. So I ended up with 58 when I did 90 minus 32. So let's check that real quick. Let's actually just double check. And let's go sine of 58. And we got 0.848. Awesome. Okay, so sine of 58. So just to kind of reiterate what we did here, we're going to show how I find the angles that we're figuring out to get exactly what we're doing here. So for this first example, we had theta equals 50. So we needed to find beta. Okay, and we knew that beta equals 90 minus theta. So 90 minus 50 got us to 40, which is what we ended up putting right here, okay? And then in this next problem, this was pretty much the exact same thing. Notice that these two equations are essentially the exact same, okay? So this time we had beta equals 32 degrees. And let's get our degree signs in there, just so everybody remembers. And we ended up trying to find theta, which is going to be 90 degrees. Again, I'm just using this one right here, minus beta, which is 32 degrees. This is going to be equals 58 degrees, which is what we ended up putting here, okay? So all you guys really need to take out of this first part is that the way that these angles relate, you're going to look at the first angle, and then you're just going to do 90 minus that angle to get your second angle. And then you can double check by checking sine of 50 equals 0.766, cosine of 40 equals 0.766. That's how you're going to be able to double check your answer. The same thing here. Cosine of 32 is 0.848. Sine of 58 is 0.848, okay? So I hope that that's pretty clear to you guys. Again, this isn't the part of the lecture or the assignment that I'm really interested in you guys understanding. It's very basic. What we're going to get into next here is going to be the stuff that is really important, okay? So we just have a few examples here to go over all this, and we're going to do a couple story problems as well. And this stuff is actually really interesting because before we even jump into it, I'm going to use kind of this section of my note sheet to just talk about some things we've gone over throughout the whole year, and to show you guys that like there are inverses to things, okay? So everything that we've talked about in math, there's always like a function and then there's the inverse function. So in this left column, I'll say, what is the function? And in this right column, I'm going to say, what is the inverse of that function? And this is just to kind of demonstrate what we're going to be doing next, okay? So like you had addition, well, the inverse of addition is subtraction. That's kind of like the opposite. It undoes addition. Same with multiplication. We had multiplication, which I always use dots, and then we have division, which is kind of like this. It also applies to like exponents. So we have like, what were some of our exponent rules? Like square roots and exponents. That's a really good one. So like x to the second power, the square root I just gave the answer. The inverse of the second power is the square root of x, okay? So now the reason that I'm bringing all this up is to just sort of show you guys that these end up being, they look a little different sometimes, like second power, square root. Those don't look the same at all. But what we're going to talk about with trig functions, this is where it's like very straightforward the way that your calculator is going to do this, okay? So we need to recognize that for sine, so like when I go into my calculator here, for any of these functions, sine, cosine, tangent, if I go to the inverse in my calculator, it says sine to the negative first, cosine -1, tangent -1. Those are the inverse functions. So just for an example, I'm going to write sine of -1 right here of like x, or I'm sorry, I should actually just put sine right here. This is just sine. So the function is sine of x. That's something that we've talked about. And the inverse of that is going to be sine to the -1 of x, okay? So this is really what we're going to be talking about with today's lesson, is these inverse functions. And these are like really, really useful because you can have just the ratios that we've talked about so far in class, and just with the ratio, we can figure out what the angle is, okay? So another little table that I'm going to do here is just talking about the 3 trig ratios. So I'm just going to set this up right here, and we're going to have our trig function on the left, and then we're going to have the parts of the triangle or triangle legs on the right. Triangle leg ratio, let's call it that. Okay, so we have our 3 trig functions, sine of x or theta, whatever, cosine of x or theta, and tangent of, we're going with theta, okay, and we can all see that, awesome. Okay, so let's just remember, and the reason that I'm doing this is because we want to be able to recognize, given what's in each of these triangles and where the angle theta is, we want to recognize what trig function we need to use, okay? So when I'm looking at like sine of theta, well, if I go back to SOHCAHTOA, I remember that sine is opposite over hypotenuse. So opposite over hypotenuse. Cosine is adjacent over hypotenuse. So ADJ over hypotenuse. and tangent is opposite over adjacent. And again, you guys, so much of trigonometry is just identifying which pieces of the puzzle you really need and which ones you have in order to get the right answer, okay? So we're gonna do this first example here, and we're gonna refer back to this, okay? So the first thing I wanna look at is where the angle is. The angle theta is right here. It's in this corner. Okay, and so we have two leg measures here. We have 12, and when I look at 12 relative to this angle, that's the opposite one, okay? That's the leg length across from the angle that's opposite. So this is OPP, opposite. And then we also have the hypotenuse. So we remember the hypotenuse is always across from this right angle, okay? So we go across there, and this is hypotenuse. It's always like the diagonal leg of a triangle, okay? So we've got the hypotenuse right there, and we have opposite. So now I'm gonna go into my trig functions and see which one I need to use. So I have opposite and hypotenuse. Well, that works for sine. We have opposite and hypotenuse, okay? So that's how we're gonna set this up. We have the trig ratio, and that's step one, set up the trig ratio. So we're trying to find the angle. So I'm gonna be looking here, and I'm gonna go sine of opposite over hypotenuse. So 12, or actually, I'm screwing that up a little bit. That's okay though. Sine of the angle, theta, equals 12 over 13, okay? So sine of theta equals opposite over hypotenuse. Sine of theta equals opposite is 12. Hypotenuse is 13. Okay, so we've set it up. We're in good shape. This is kind of what we did in like unit 10A. So now what we need to do here is we're kind of the same way that we would do like things. We would do inverses of things in previous units to cancel things out. That's exactly what we're doing here to sort of cancel out the sine on the left and to end up getting the sine inverse of this, and that's what's gonna give us our angle, okay? Because we want the angle by itself. So what I'm gonna do here, I'm just gonna bring this over and we're gonna set this up very normally. We're just gonna bring it down. Okay, and so now I'm gonna do sine inverse of both sides. I'm gonna go back to the sine inverse. And the reason that I'm doing that is because that's basically what undoes sine and gets the angle by itself. So basically what I'm saying here is like sine inverse, and then if I were to put like brackets of sine of theta, and anything I do to one side, so I did sine inverse on the left, I have to do on the right as well. So I'm gonna go sine inverse of 12 over 13. Okay, and so these cancel out, and really at the end of the day, what we're doing here is we're just saying theta equals sine inverse of that ratio, 12 over 13. Okay, so this is the way that we solve for theta all by itself. So we kind of went through this the long way, but we're gonna do it the short way with these two examples. Let's finish up this example here to get our answer, and then we'll do the next two examples. These are really like one-step problems, you guys. Okay, so what I'm gonna do here is I've got my calculator. I hope we can all kind of see that. I'll zoom in on it at the end of the problem just so you can see. And so I'm finding sine inverse, and then I'm doing 12 divided by 13. And then I'm pressing enter. And I'm getting 67.38 degrees. Again, I'll do that one more time. So this is sine inverse of 12 divided by 13. And so we're right there, sine inverse 12 over 13. And I get 67.38 degrees, okay? And that's it, you guys. We just figured out that theta equals 67.38 degrees. And we're basically good now. That was our answer. That's all we need to do. Okay, so we're gonna do this again with these two examples. And then we're gonna get onto the story problems. We're 14 minutes in, so hopefully we'll keep this under a half hour. I think we can do that. Okay, so now for this next example, let's kind of give these a little space, something like this, to separate the examples from the tables. There's a lot going on here. Okay, so I'm onto this example here. And what we're doing now is it's the same thing. The first step is to identify the angle where it is and set up the trig ratio. Okay, so I've got the angle theta is in this corner. And we have two values here. We don't have a hypotenuse. We're missing this, okay? Because remember, this is like our right angle. So we're missing the hypotenuse. But we have a leg length here and a leg length here. So because theta, our angle theta that we care about, is up here, if I'm finding the opposite, that's the one that's like across, okay? That's the one that is not touching the angle, okay? So it's straight across, so this is opposite. Now we have this one as well, and this is not the hypotenuse, but it is touching the angle. So if it's not the hypotenuse and it's touching the angle, then this is our adjacent side length. Okay, so now what we got to do is we have an opposite, we have an adjacent. So we're going to go through our trig functions and see which one we should use. So the first one, sine, that's opposite and hypotenuse. So we can't use that one. Cosine is adjacent and hypotenuse. We don't have a hypotenuse, so we can't use that one. Tangent is opposite and adjacent. So that's the one that we're going to use here, is tangent. So we're going to set it all up like this. We're going to say tangent of theta equals, and now let's go back, that's opposite over adjacent, so I'm going to put 24. You know what, let's actually move this down a little bit. Tangent theta equals 24 over 10. Okay, and so now the next step is kind of to just do this long thing. So we're not going to be using sine inverse, we're going to be using tangent inverse. So really, to get theta by itself, now what I'm going to do here is I'm going to say the next step, we just go from tangent of theta equals 24 over 10, and we say theta equals the tangent inverse of 24 over 10. Okay, so now we can just go into our calculator, and this is very straightforward. I'm right here in the tangent inverse, and I do 24 divided by 10. Okay, so this is what it looks like in my calculator, you guys. Tangent inverse equals 24 over 10, and I press enter. And crazy, I get 67.38, which is wild because it's the same exact angle measurement we had in the first one. So theta equals 67.38. So what that really means between these two examples is that these are probably similar triangles, which is kind of cool. Okay, and so a way that we can check our answer here is so real quick, let's just evaluate 24 divided by 10. So you don't need to do this, but we're going to do it anyway. So 24 divided by 10, that's going to give me 2.4. So 24 over 10 equals 2.4. So now if I do tangent of 67.38, I'm hoping that I'm going to get this ratio of 24 over 10. So let's see if it works out. So I'm going to go back to my regular tangent function, and I'm going to do tangent of that angle, 67.38. And again, you guys, we're not going to get the exact answer, but I think we're going to get pretty close. 2.3999, so that's basically 2.4. So this is our way to double check our answer, make sure we did it right. So we're good here. This example is complete. So we've got one more before we get into the story problems, and we are 18 minutes in, so we're doing all right. Okay, so our last example here, again, the first thing we're gonna need to do is identify the angle theta, that's right here. Okay, so what we don't have here is an opposite leg measurement. Okay, so we do have an adjacent and a hypotenuse. The hypotenuse is always the easiest one to recognize because it's the big diagonal that's across from the 90-degree angle. So this is hypotenuse, HYP. This is our adjacent side length, ADJ. So now we're going to go through our trig functions and we're going to see which one has adjacent and hypotenuse. So sine, that's opposite, so we can't use that. Cosine has adjacent and hypotenuse, so that's the one we're going to use. So we're going to set this up as cosine of the angle theta equals adjacent, which is 9, over hypotenuse, which is 12. Okay, so now, again, this is really straightforward. To get theta by itself, all we're doing is the cosine inverse of both sides, okay? So when we do it to the left, they cancel out and we're left with just theta equals cosine inverse of 9 over 12. So this is all you guys really need to know how to do here, is take this cosine of the angle equals some fraction, and then be able to understand that all we need to do to go from this step to this step is we get the angle by itself on this side, and we get the inverse trig function with the ratio inside on the other side, okay? This is what we're doing here. So now again, I'm gonna go back into my calculator, I'm gonna clear out the previous example, and we need to go to the inverse, and we're gonna go cosine to the negative first power of 9 over 12. And then we press enter and we get about 41.409, so about 41.41 degrees, okay? So we got the angle theta equals 41.41 degrees. And that looks to be about right. So now let's double check it. Let's just go backwards and kind of double check our math. And so 9 over 12, that's going to be 3/4. That's 0.75. So 9 over 12 equals 0.75. So I'm going to check, I'm going to go back to cosine of the angle 41.41 to check our answer. And I get about 0.75. So that's how we know we did it right, okay? So we are 20 minutes in. I think we're in good shape. I hope this all kind of makes sense to you guys. Really all it is it's getting the right trig function and it's doing the inverse trig function. Excuse me. I don't think I've talked this long straight, probably since I recorded the last video, so my throat is all hoarse. So 41.41 degrees, 67.38 degrees, 67.38 degrees. I hope you guys can figure out how to get these answers with the example. So now we're going to move on to the story problems. Okay, so we have 2 of these, and these are actually super easy to set up when you just read them, as long as you understand like what the different words mean, okay? So the first one, a helicopter is hovering above a road at an altitude of 24 meters. At a certain time, the distance between the helicopter and the car on the road is 45 meters. Calculate the angle of depression, okay? So really, we just need to find an angle. That's what this is asking for. So we've got a triangle to start. And we know that the helicopter is hovering above the road. So if this is the road, the altitude is 24 meters. So we're going to put 24 meters. At a certain time, the distance between the helicopter and a car on the road is 45 meters. So let's say this is like a little helicopter, okay? I'm going to like just totally botch trying to draw a helicopter, but that's okay. I've been playing a lot of Call of Duty Warzone, and there's helicopters and cars and stuff in that game. It's pretty fun. And then we've got like a little car here with wheels. Okay. So the altitude above the road is 24 meters. The distance from the helicopter to the car, at a certain time, the distance between the helicopter and the car on the road is, so the distance we're going to be measuring is actually, I think that's going to be here. That's how I'm interpreting this. The distance is 45 meters. Okay, because we're not talking about like the distance between the car and where the helicopter is, you know, like this. The way I'm interpreting this is that 45 meters goes here. Okay, so now we want to know the angle of depression from the helicopter to the car. So really what that is it's the angle that occurs right here, but it ends up being, due to alternate interior angles, it ends up being this angle. So if a lot of that was kind of like all over the place for you guys, my apologies, but really if you can just tune in at this point and understand that we have the angle here, we have the height here, we have a leg measurement, and we have a hypotenuse leg measurement. So we have everything we need to figure out how to solve for what this exact angle is, okay? So given this angle, 24 meters is going to be our opposite side length, okay? Because it's not adjacent. Adjacent's right here, and it's not the hypotenuse. Hypotenuse is here. So we have opposite, and we have hypotenuse, HYP. Okay, so now let's go back to our trig functions. Opposite and hypotenuse, that gives us sine. That's what we're looking for here is sine. Okay, so what I'm going to do is I'm going sine of the angle theta equals opposite, which is 24, okay, divided by hypotenuse, which is 45. And again, once we have it set up like this is all in the setup, you guys. Once we have it set up correctly, the real trick here is to just use the sine inverse, okay? So sine inverse of the left side. Again, we'll go through it the long way one more time just to show you. Sine inverse of sine of theta. What that does is the sine and the sine inverse cancel out, and we're left with just theta on the left. But because we did sine inverse on the left, we do it on the right, and we go sine inverse of 24 over 45, and then we can evaluate that in our calculator. So I'm going back to my calculator, I'm clearing it out, and I'm going inverse, sine inverse, whoops, I accidentally doubled it. Okay, so sine inverse, and then it was 24 over 45. 24 over 45, and I press OK, and that gives me 32.23 degrees, okay, right there, 32.23. And again, we're rounding a little bit because it doesn't make a lot of sense to write that entire number out. So theta equals 32.23 degrees. And that's it. That's our angle. That's the angle that we were asking about here, okay? So we're gonna go through one more. Mark, maybe it's Mark Dawson again. Mark, you love flying kites, don't you, from third period? Mark is flying a kite and he realizes that 300 feet of string are out. Okay, so let's draw. We got Mark right here. And he's got the kite like in his hand. And the kite is like up here. And what do kites look like? Kind of like that, right? So Mark's got his kite and he's got 300 feet of string out. We also know that the kite is 250 feet above the ground. What is the angle of elevation from the ground to the string of the kite? Okay, so we're just going back to this angle right here. And this is going to be exactly the same setup as the previous story problem, okay? Because we had the angle here, we have an opposite length, and we have a hypotenuse. This is our right angle right here. So we're going to set it up exactly the same way. We're going to go sine of theta equals opposite. Again, we can give these labels. Opposite over hypotenuse. So sine of theta equals, opposite is 250 over hypotenuse is 300. So now we're just doing sine inverse on both sides, remember. And we end up with theta equals sine inverse of 250 over 300. So now we'll evaluate this in the calculator one more time. We're going sine inverse of 250 divided by 300, and we get 56.44 degrees. So theta equals 56.44 degrees, and that is it, you guys. We are done. Okay, so we hit just inside the 30-minute mark with a couple minutes to spare. If you have any questions on this stuff, you guys, just please reach out to me. I'm also going to connect, I'm going to look for a good Khan Academy video that will go with like the assignment for the notes, okay? So this is going to be the one you can watch if you kind of wanted to see me going over everything, but there will be another link to another video if you guys kind of want a different perspective. So I hope this helps out. I hope you guys are all doing well and just taking care. I miss you guys. I freaking love you guys, and I guess I'll see you in the next video.